She is angry and sad, and we want to make her happy using AI. We want her to look like this, or like this, or like this, or like this, using AI. We will learn how to do that from scratch, and we can even make her look young and happy. So this is the workflow. Let's start from scratch. I want to erase all that. And I will start by loading the image. The original image was generated using AI. I just generated an image of a woman standing in front of a textured wall, and she looked like very sad to me. I wanted to make her happy. So the first thing we do is we upscale the image. And to upscale, we upscale the image because we want to get more pixels to work on so that we can get a better result. So I will load an upscale model, and I have a few upscale models. This one works nice for me. And now we need to upscale image using model. We pass the image, we pass the model, and we preview the resulting image. I don't want to save it, I want to preview it. Then we need to work on something that can handle faces. So first thing, we need a model to work on the face, and we need a model that we know is good with faces. So XL Turbo is good with faces, but I think Dreamshaper is better with faces. And I want a sampler that can work with faces. So if I look for face, I see the face detailer. Let's try this one. The face detailer takes a model, clip also, and VAE to encode and decode the image. Here is the image. It requires prompts, so let's give it a prompt. Clip text encoder, and I want it to show me a smiling woman. We clip it with the model. The clip is the connection between the text and the image, the training of the model. And I can also copy this node by pressing Alt while I drag it, and now I can connect the positive and the negative. I want a box decoder, but my box decoder, it did not work well. We could have made her more sad if we connected the smiling woman to the negative. I want a box decoder, but my box decoder, I want to something to find the bounding box around the head. And I see this one can work well. So clip segment detector provider, yes. And here I wanted to find a head and make a box around the head. These parameters are fine. Segment anything model is not required. I don't want to add a segment because I want to detect the head and work around, work inside it in this box. So I can add another model that would segment the image, but now it's not necessary, and all the SAM options here are not necessary. The other options are sometimes confusing. So this max size is actually what this means is if we have a big image, we will split it to chunks, segment it into segments of 1024 by 1024 max, and work on it. But in our case, like the head, the area that we will work on is a lot smaller, so this is not necessary. Our model is based on Turbo. So Turbo and DPM++ and DSE. So since it is based on Turbo, it can work with 6 to 8 steps maximum. And we have a small area, so 6 steps is fine. CFG, I tested multiple values and I found that I can work well with 2. The sampler name is DPM, the appropriate for the model. And the scheduler would be Keras, also the appropriate for the model. Denoise is very important because this means the amount of pixels we have the right to change. If I put it at 1, I will get a completely different face. So I don't want that. I want to change a few of the pixels. So if I put it at 0.5, I got the smile. Let's get the smile now. If I put it at 0.2, for example, I get a small change, but she looks smiling, and I showed you that in the introduction. So now I want to get the full smile. The feather is how we want to change the borders of what we are going to change. We want a noise mask, and we know we force in paint because we want to paint inside the image. The bounding box threshold, it works fine with 0.2, I found. So I want fine grain control around the bounding box. I want it to blend with the surrounding areas. And the other things are not interesting, and 1 cycle is enough. And let's see the result. So I can save the image here, and I'll save it as a smiling woman. And I want to show the mask as well to see how my bounding box is doing. So I can make it mask to image, and I can preview the image here to see what my mask, my bounding box provider has done. And this is the entire workflow. So let's try it. Do we have a mistake? Because I processed the same image before, I did not get the preview. It is still in the RAM. As I said, I did not get the preview here because I just processed that photo. The model was loaded, so everything like the output of these nodes was still in the RAM. Because I have a randomizer here, I'm getting a new image. So we have now our upscaled image. Let's look at the bounding box, and I think it works fine, worked well. And let's open our smiling lady, and we see the smiling lady. Let's compare it with this one. It's almost the same image. The seed was different. I generated it with the same values. The seed was different. This was generated also with 0.5, but this looks nicer. This one is with 0.3, and this one is 0.2, and this one is the upscaled image, and this one is the original image. Let's put it at 100%. So now 200. Normal upscaling without processing by model. Now processing by model with the denoise 0.2, denoise 0.3, denoise 0.5, Also denoise 0.5 with different configurations. I think this one is CFG 4 and this one is CFG 2. This one is also the same result. And this one with changing, I changed the prompt to smiling girl instead of smiling lady. And with 0.5 denoise, I got this image. And this was the original, this is the workflow that we used it. As I said, it did not go to this step because I have just upscaled the image, so it was still in the RAM. If you like this video, check my first video on how I did the Stable Diffusion XL workflow from scratch as well. And I also do tutorials for developers. I run a series called the DevLab Show, where I build development environments using automation, which is something very interesting for developers if you like. And I did also an environment on a development environment on how to prepare for AI development, in which we did a comparison. We did a small script to do a comparison between large language models that you can install locally and work with locally. If you like my channel, please subscribe, and I hope to see you in the next video.